Hello everyone. On this video we will be looking at quadratic functions and their graphs. Okay, now the definition of a quadratic function is it's a second degree polynomial that can be written as ax squared plus bx plus c equals 0. Okay, so you could have f of x equals 2x squared plus 7x plus 5. Okay, so as long as that first a value doesn't equal 0, you have a quadratic function. Okay, so now we're going to look at the graph of a quadratic function. Okay, so just kind of sliding that up. To do that, the first thing we're going to understand is the vertex. Now the vertex is either the maximum or minimum value of your quadratic function. Now when you graph your quadratic function, it's either going to look something like this or it's going to look something like that. It may be thinner, it may be wider. It all depends on your values of A, B, and C, but it'll always look like one of those. Okay. Now, when you have a quadratic graph that looks like this, the lowest point on the graph is your vertex. Okay, and that's your minimum value. Now, when you have a graph that's kind of opening downward, your vertex will be right here, and that's your maximum value. And of course, that's your vertex. Okay. Now, when you have your quadratic function, if your a is positive, then your quadratic value will open, your quadratic function will open upward. So, if this is a positive value, your graph will look something like this. But if your a is a negative value, then your graph will look something like this. Okay, so that will definitely come in handy. Okay, so first let's look at a couple of examples. Okay, so if you're still writing, please feel free to press pause, but we're going to go ahead and move on. All right, slide this down a little bit. Okay, so for these examples, for the first one, we want to determine whether the graph of negative x squared minus 14x minus 7 opens upward or downward. Alright, so to solve this, I'm just going to rewrite it. Negative x squared minus 14x minus 7. Now remember, we're looking at the term y equals ax squared plus bx plus c. Okay. Now in this case, your a is equal to negative 1. Okay, so we know that since a is less than 0, the graph will open downward. Okay. Now we don't have to necessarily graph it on this one. We'll do that a little later. But this just wanted to know whether it opens up or down. Okay. So same thing with this next example. We want to determine whether the graph of f of x equals 9x squared plus 5x plus 33 opens upward or downward. Okay. And just to point out, it could be either f of x equals that function or y equals that function. Just the very same thing for either one. So if it's y or f of x, it's the exact same thing. Nothing changes. Okay, so for this one, we have y equals 9x squared plus 5x plus 33. Now in this case, your a is equal to 9, which makes it positive. So since a is greater than 0 in this case, the graph will open upward. Okay, so again, when the graph opens downward, it looks kind of like that. When it opens upward, it looks something like that. And again, it could be narrow, wider. We'd have to actually graph it, which is what we're going to do a little bit later in the video. Alright, so once again, if you're still writing, please feel free to press pause. But we're going to go ahead and move on to our next example. Okay, but before we do that, we're going to look at what we call the formula for our vertex. Okay. Now, if we have our f of x equals ax squared plus bx plus c, or y equals ax squared plus bx plus c, your vertex will equal, for your x value, negative b divided by 2a, getting your a and b from over here. And then you're going to plug that value right back in. So you have f of whatever that negative b divided by 2a is. Okay. Now also, just kind of a step back a little bit, just a reminder that we're going to be using intercepts on a lot of these, well, a couple of these examples. So to find your intercept, you're going to make your y equals 0, or your f of x equals 0. And to find the y intercept, you're going to make your x equals 0. Okay, now probably a new term will be your axis of symmetry. Okay, now your axis of symmetry is a line that you can draw down the middle of your quadratic formula or quadratic functions graph, and both sides will be equal. Now, in order to find the axis of symmetry, all you have to do is solve for the x value of your vertex. So x equals, you go up to your vertex, negative b divided by 2a, that's your axis of symmetry. Okay, so if you drew, let's say, a graph and it looks like that, assuming that both sides, and this is your vertex, your axis of symmetry is a vertical line right through your vertex. And both sides of that graph will look just like mirror images of each other. Okay, so this side will look just like that side. All right. Okay, so let's go to our first set of steps in order to draw our graphs. Okay, again, if you're still writing, feel free to press pause, but we're going to go ahead and move on to our steps for graphing quadratic functions. Okay, so the first thing you want to do is you want to put it in the form f of x or y equals ax squared plus bx plus c, and identify your a, b, and c. Alright, now the second thing you want to do is you want to find your vertex using the vertex formula. Okay, so that's the very same formula we had on the previous page. Okay, now your third step is you want to pick at least 2 values of x as your additional points on the graph. And a lot of times you can use your x and y intercepts. That's why we went over them on the previous page. Okay, you don't have to use the x and y intercepts, but a lot of times it's just really convenient. Okay. Then the last thing you want to do is you want to plot your vertex and the points from step 3 on your graph. And then you just go ahead and connect them. Alright, so if you're still writing, please feel free once again to press pause and finish up. But we're going to go ahead and look at our first example where we're going to do some graphing. Okay, so what if we wanted to graph f of x equals negative 2x squared minus 8x minus 8. Alright, so let's go ahead and get started. Okay, so look at our first step. It's already in the form that we want. So we have f of x equals negative 2x squared minus 8x minus 8. Now to identify our a, b, and c, our a is equal to negative 2. Our b is equal to negative 8. And our c is equal to negative 8. Okay, so that part's pretty straightforward. Nothing really mind-blowing there. Now, for our second step, we find our vertex. And if you remember, your vertex is your negative b divided by 2a and f of negative b divided by 2a. Alright, so we know that our x value, which is negative b divided by 2a, will actually equal negative, your b is negative 8, so that's negative 8 divided by 2a, so 2 times negative 2. Okay, so that will give you negative 8 is positive, so you have 8 divided by 2 times negative 2 is negative 4. 8 divided by 4 is 2, positive divided by negative is negative, so we know that our x is equal to negative 2. Okay, so that part we have. Now we get that value and we plug into our function. So our f of negative b divided by 2a is just f of negative 2. Okay, so if we replace every x with negative 2, that's going to be negative 2 times negative 2 squared minus 8 times negative 2 minus 8. Okay, so that's our f of negative 2. So that gives us negative 2 times negative 2 squared is positive 4. Minus 8 times negative 2, so that will be plus 16 minus 8. Okay, so in this case, we have negative 2 times 4, which is negative 8, plus 16 minus 8. Minus 8 and minus 8 is minus 16. Minus 16 plus 16 is 0. So that lets us know that f of x is equal to 0 for our vertex. Okay, so we know that our vertex, I forgot my equal sign there, is equal to negative 2, 0. Okay, so we know what our vertex is. Alright. Okay, so now we go ahead and go to our third step. And for our third step, we're going to find 2 points. Okay. Now we're going to go ahead and use our x and y intercept only because it's easier. Okay, so to find your x-intercept, we make our f of x equal 0. So that means we have negative 2x squared minus 8x minus 8 and we just make that equal 0. So negative 2x squared minus 8x minus 8 equals 0. The good thing about this is all of these are even. So if we divide each term by negative 2, okay, anything divided by itself is 1. So we have x squared plus 4x plus 4 equals 0. And this can actually be factored into x plus 2 times x plus 2 equals 0. Okay, so if we set both of those to 0 and solve, we end up with x equals negative 2. Okay, now unfortunately, whenever you end up with the same x value as your vertex, you have to pick a different point. Okay, so same as vertex. So we can't use. Okay, which means we just pick another x value. Okay, now for your y, you can use your y-intercept, as long as it doesn't turn out to be the same as your vertex. So for your y-intercept, you just make x equals 0. Okay, so you have y equals negative 2 times 0 squared minus 8 times 0 minus 8. Okay, the reason this is so convenient because the zeros, just cancel those out. Negative 2 times 0, 0, 8 times 0, 0. So you just have y equals negative 8. So your y-intercept is when x equals 0, y equals negative 8. Okay, so we have one of our points. We would have had two if this would have been a different x value and it didn't match that one. Okay, so we have our y-intercept, we have one of our points, so now we just go ahead and find a different point, and we'll continue that on the next page. Alright, so if you're still writing, please feel free to press pause. I'm going to go ahead and continue on the next page. Okay, now since we couldn't use the intercept on the last, well, the x-intercept, we'll let x equal negative 1. Like I said, it doesn't matter what our other point is. I just use the x and y intercept out of pure convenience. Okay, so that means that f of negative 1 is equal to negative 2 times negative 1 squared minus 8 times negative 1 minus 8. Okay, so that's going to equal negative 1 squared is positive 1. 1 times negative 2 is negative 2. Negative 8 times negative 1 is positive 8. Minus 8. Those two cancel each other out. So that equals negative 2. So our second point, okay, when x is equal to negative 1, y is equal to negative 2. Or your f of x is equal to negative 2. Okay, so now we go to our fourth step, which is we're going to graph. Okay, now we found what we need. Our vertex is negative 2, 0. Our y-intercept is 0, negative 8. And we couldn't use our x-intercept, so our third point that we found up here is negative 1, negative 2. Now, if you look back to the original function, we see right here, f of x equals negative 2x squared minus 8x minus 8. I'll just go ahead and rewrite that. F of x equals negative 2x squared minus 8x minus 8. We see that a is less than 0. So our graph is going to look something like this. It's going to be open downward with our vertex being right on top. Okay, so we kind of knew that right from the very beginning, before we started calculating anything. All right, so let's go ahead and start graphing. So if you like, you can press pause and draw out your graph. All right, so first let's plot our vertex. So we have negative 2, 0. Okay, so that's our negative 2, 0. Okay, where in this case, x equals negative 2 is the axis of symmetry. And I'll show you how that comes in handy when you're graphing. Okay, so we have our point 0, negative 8. So x is 0, y is negative 8. That's right there. And we have our point negative 1, negative 2. So we have negative 1, negative 2, which is about right there. Okay, so this graphs up. And excuse if it's not the prettiest graph. It's kind of what happens when you're drawing by hand, but of course it'll look better if you use a program. Alright, so we have that. You kind of clean that up a little bit. Alright, there we go. Okay, so your left half of your graph will look something like that. Of course, a whole lot prettier. My drawing skills are not that great, so excuse how that looks. Now remember, this is your axis of symmetry, your x value. So it goes right through there. Now the reason you only need 2 values or 2 points is because if you notice here, your x is equal to negative 2. This goes from negative 2 to negative 1. We know it's at negative 2 here. So this side, if you go 1 point over on the same y value, you know you have a point here because these sides are both symmetric. So if you're 1 over on this side, you're going to be 1 over on this side. Okay, so we know, even though we don't have the point calculated, we know it's going to look something like that. It's going to go over. Okay, same thing here. We have 0, negative 8. We know it's going to be the same thing. We went from 3 to negative 4. So from negative 2, went from negative 1 to 0. So we're going to go from negative 2 to negative 3 to negative 4. And that's also going to be right on negative 8. Okay, so we're going to go ahead and draw that. So even though it's not the most detailed graph, that's kind of how your graph will look. So again, it will look a lot better if you're using your program. But by hand, your graph will look like that. Okay. Like I said, just remember, once you have your points on this side, if this is a distance of 1, this is going to be a distance of 1. If this is a distance from your vertex of 2, this is going to be a distance of 2. And you have your maximum value. Alright. Okay, so if you are still writing, feel free to press pause. But we are going to go ahead and move on to our next example. Alright, so what if we wanted to graph y equals x squared minus 2x minus 8, and this time we're instructed to plot using the x and y intercepts. And again, you don't have to, you'll get the very same graph either way, but usually if they're telling you to use the x and y intercepts, then they're probably trying to guide you in the easiest direction. So the x and y intercepts, probably the easiest way to go. Okay, so again, we go to our first step, where y equals x squared minus 2x minus 8 is in the right form. So we know our a is equal to 1, our b is equal to negative 2, and our c is equal to negative 8. Okay. So now we go ahead and go to our second step, where we find our vertex. Okay, so just like before, our x value of our vertex is equal to negative b divided by 2a. Or the negative can be in front if you want it. Okay, so that's equal to negative 2 divided by 2 times 1. Just plugging in our a and b from up here. Okay, so negative 2 is positive 2. And 2 times 1 is 2. Anything divided by itself is 1. So we know the x value of our vertex is x equals 1. And we just plug that into our function. Okay, so that gives us y equals 1 squared minus 2 times 1 minus 8. Okay, so 1 squared is just 1. Negative 2 times 1 is minus 2. And we have our minus 8. So that's equal to negative 9. So we know that our y is equal to negative 9. So that gives us a vertex of 1, negative 9. Okay, so now we go to our third step, where we find our x-intercept by making y equals 0. Okay, remember last time it was f of x equals 0. This time it's y equals 0. Okay, so we have x squared minus 2x minus 8 equals 0. I just kind of flipped it around. You don't have to, but I just find it a little more appealing to me. So x squared minus 2x minus 8 equals 0. Alright, so now we know that this can be factored into x minus 4 times x plus 2 equals 0. Okay, so if we set both of those to 0, we have x minus 4 equals 0 and x plus 2 equals 0. Okay, so we have x equals 4 once we add 4 to both sides. And we subtract 2, we have x equals negative 2. So our x-intercepts, in this point, we have 2. We know that when x is equal to 4, y is equal to 0. And we know that when x is equal to negative 2, y is equal to 0. So we actually have 2 x-intercepts. Okay, so now we go ahead and find our y-intercept. And we do that by making x equals 0. Okay, so again, we have our, let me move this down a little bit, y equals x squared minus 2x minus 8. So that will become y equals 0 squared minus 2 times 0 minus 8. Where those two just become 0, so they disappear. So you have y equals negative 8. So our y-intercept is when x is equal to 0, y is negative 8. Okay, so we have our x-intercept and our y-intercept. Alright, so we can go ahead and continue this on the next page. Now remember, if you're still writing, feel free to press pause and get everything jotted down. But we're going to go ahead and move on. Thus. Alright, now we go to our fourth step where we go ahead and graph. Okay, now remember, you have your vertex, which was 1, negative 9. You have your x-intercept, which is 4, 0, and negative 2, 0. Kind of clean that up a little bit. And we have our y-intercept, which is 0, negative 8. And remember, you have y equals x squared minus 2x minus 8, which lets us know that since your a is equal to 1, your a is greater than 0. So we know here that your vertex is a minimum value. Okay, so it opens up. Alright, so if we're going to go ahead and graph it, we're going to need to plot our points. So 1, 2, 3, 4. Move this down a little bit more. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 7, 8, 9. Okay. Okay, so now we go ahead and we plot our vertex. Okay, so remember our vertex is negative 1, 9. 1, negative 9. Sorry about that. So we have 1, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's about right here. That's your vertex. Okay. Now we're going to go ahead and plot our x-intercept, which is 4, 0 and negative 2, 0. So 4, 0 is right here and negative 2, 0 is right there. Okay, so last but not least, we're going to plot our y-intercept, which is 0, negative 8. And 0, negative 8 is right there. Now we go ahead and this side is going to go there. Remember, your vertex is your lowest point, so once you hit that, it's just going to go right back up to your value here. Okay, so that one looks a little bit better than our previous drawing, but this is how your graph will look, and of course it'll look a lot better if you're using a program. Alright, so this is your graph. Okay, so let's go ahead to our next section. Remember, if you're still writing, feel free to press pause, but we're going to go ahead and move on. Okay, and this time we're just going to look specifically at the minimum and maximum value problems. You have some problems where that's all they're going to ask you about are your minimum and maximum values. Okay. Remember, when a is greater than 0 or your a is positive, the vertex is the minimum value. When a is negative, the vertex is the maximum value. All right. So let's go to our minimum and maximum value problem. Okay. So our example is find the minimum or maximum value of the function f of x equals 10x squared plus x minus 9. Alright, so let's go ahead and solve this one. Okay, so the first thing we want to notice is for our f of x equals 10x squared plus x minus 9 is that your a is equal to 10. Okay, so a is equal to 10, which means that a is greater than 0. B is equal to 1, and C is equal to negative 9. Okay, so just because your A is greater than 0, we know it's going to have a minimum value. A is greater than 0, so the function will have a minimum value. Okay, so now we go ahead to our second step, which is we find our vertex. Okay, so we know that the x is equal to negative b over 2a, which is equal to negative b is negative 1. You can put the negative up top if you like. It doesn't matter if it's in the front or up top. Both of them will give you the same answer. So you have negative 1 over 2 times a, which is 10. So that gives us negative 1 over 20. So we know that x is negative 1 over 20. And we plug that into our function. Okay, so that means f of negative 1 over 20 is going to equal 10 times 1 over 20 squared plus, negative, sorry about that, negative 1 over 20 minus 9. Alright, so if we go ahead and start simplifying, negative 1 over 20 squared is 1 squared. Well, negative times negative would be positive, so that would be 1 squared, which is 1, over 20 squared, which is 400, plus minus, well, plus negative 1 over 20 is just minus 1 over 20, minus 9. Okay, so this will give us the 10 and the 400 will actually simplify. So that's, instead of 10 over 400, you'll end up with 1 over 40 minus 1 over 20 minus 9. All right, so we can't add or subtract fractions unless they all have the same denominator. So we're going to make this 1 over 40 minus the 1 over 20. We can actually make that 20 equal 40, so we'll multiply this by 2 over 2. Minus, and instead of 9, we'll make that 9 over 1, and multiply that by 40 over 40, just to give them all the same denominator. Alright, so that gives us 1 over 40 minus 2 over 40 minus 360 over 40. Okay, so 1 minus 2 is negative 1. Negative 1 minus 360 is negative 361 over 40. Okay, now when they ask for the minimum or maximum value, that's your f of x or your y value. That's the minimum or maximum value. Remember, the x is your axis of symmetry, but your minimum and maximum value is actually your y value. So your graph will look something like that, where this is your vertex, and that's going to be the point negative 1 over 20, negative 361 over 40, where that's your lowest y value. Okay, every other y value is going to be higher than that, or your minimum value. Alright, okay, so let's go ahead and do one more example, and this one's going to be a little bit of a story problem. But again, if you're still writing, feel free to press pause. Okay, so you may want to press pause and write this down, but it's a landowner who's building a fence, or fenced-in rectangular patio using his garage as one of the quote-unquote walls. He wants to maximize his 80 feet of fencing. The area of the patio is AX equals X times 80 minus 2X, where X is the width of one of the sides. You want to find the maximum area. Okay, so I'm assuming you've pressed pause and you've written all of this down. So now we're going to go ahead and solve this one. So to help visualize it, we're going to draw a little bit of a picture. Alright. Okay, so this is your garage wall. Okay, so he has all of this that he wants to use as a fence. He doesn't need the fourth side because the wall is going to be that. So this is all of your fence. So X is the width of one of the sides. Remember, area of a rectangle is length. Well, instead of the X, I'll use length times width. Okay, so that means this is your length, and if this is the area, that means you have 80 minus 2x as your length. Okay, so we want to maximize our area. Okay, so we have 80 actual feet of fencing. We want to get the largest area we can. Okay, so we have our A of x equals x times 80 minus 2x. Okay, so if we go ahead and distribute that because we want it in our quadratic form. That's 80x minus 2x squared. Or we can actually go ahead and rewrite that because that gives us a of x equals, if we kind of switch those up, negative 2x squared plus 80x. And you can put plus 0 there if you want it, just to let us know that our a is equal to negative 2, our b is equal to 80, and even though we won't use it, our c is equal to 0. Alright, so now all we have to do is find our vertex. Okay, so looking for our vertex, we know that the x is negative b divided by 2a. Kind of separate that a little bit. So that will be negative 80 divided by 2 times negative 2, which gives us negative 80 divided by 2 times negative 2 is negative 4. So that gives us 20. Okay, so we know that x equals 20, and we just plug it in. So a of 20 is equal to 20. Remember, we're just using our original formula if we want to, or you can use the extended version. Doesn't matter which one you use, same thing. But just using this one, so you have 20 times 80 minus 2 times 20. Okay, so that's going to equal, if we go ahead and distribute that. Well, actually, we don't have to distribute. We can solve this in here first. That would be a little easier. Okay, so 2 times 20 is 40. 80 minus 40 is 40. So you have 20 times 40. And 20 times 40 is 800 square feet. Okay, so actually we will have a maximum area equals 800 square feet. Okay, so that's the maximum we will have inside of there, given the 80 feet of fencing that we had. Alright, so hopefully this has helped and made sense, and I will see you on the next video.